Hello, everyone. Welcome to week 12 of Engineering Analysis and Data Science. We're going to be doing basic statistics this week of the data set that you uploaded into R last week. So basic statistics means this week we're asking you to do a t-test or an ANOVA on your data set in R. More specifically, part of your data set, so a certain amount of columns in your data set. I'm going to be going over explicitly how to do this throughout this video, but there are a few things that I wanted to review at the start. So I'm not sure if it's because you aren't watching these videos, which I'm thinking is increasingly likely, but several of you seem to still be confused about what an R script is. So this is your R script where you're writing code, you're saving code, you're making comments, you're working with your code. When you're running your code, executing it through Control or Command Enter or by these buttons, they're coming up in your console and also in your history. So for Swirl courses, since we're working right in R and I wanted to check you were doing it, you needed to upload either part of your console or part of your history. But from now on, we're only working in these R script files. The way that you get them is File, New File, R script. You can also open old R scripts and work directly in them. This is where you're saving everything. This is where you're working. To execute your command from your script, you can either run your entire, your previous code region, your entire code, or the line that you're on, or you can select or just be on a line and hit Control or Command Enter. You can also run part of a line by just selecting that. So if I wanted to just run, instead of running this whole line, if I only want to run this part, I can just select that and Control Enter, run it, or select one of these run buttons. It's a lot faster to do Control or Command Enter. All right, in addition, you can save your R script with this little floppy disk button, and it's saving as a .r file. This is what you will turn in this week. You do not need to turn in any of your history, any of your console, any Word documents, nothing. Just saving this R folder. File, save as is how you know where it's saving to and what you've named it. So all of this should be a review from last week in week 1, but since several of you were still struggling with it, I decided to address it here in this video. In addition, one thing that has come up is R is very particular about spelling things correctly, and it's particular about uppercase and lowercase. This is true for most coding languages, but it seems to be something that surprised a lot of you. So just a reminder that you have to spell commands correctly, and you have to spell them with the correct uppercase and lowercase. In addition, when you're writing true and false, it has to be uppercase. So if you're doing read CSV header equals true, that true needs to be an uppercase true. Or you can do just an uppercase T, but it still needs to be uppercase. When it's accepted as a true or false, it turns blue. So that's just a quick note. For this week, as I mentioned, we're going to be working in running some basic statistics on your data set. Things such as median, mean, and then a t-test or an ANOVA. This R file, this Word document, and this video will all be available as your resource. And within this R document and the R file, I have given you a lot of notes to help you with some additional information and tutorials as we go along. So notes about, ideas how to deal with errors, going over what's a string, which I'm going to talk about in the video, and then some basic information about statistics. Stats is a prereq for this course. So this is just a brief reminder of p-values, t-tests, ANOVA, and then pairwise, unpaired, and paired t-tests, along with how to run both an ANOVA and t-test in R. We also have these nice cheat sheets that I found online that somebody has been kind enough to make public. And you can see from these cheat sheets that it's kind of just a really brief rundown of basic R. So, help button or the help command is called up by a question mark. You can also look at installing packages, accessing libraries, things such as creating vectors, sequencing, a lot of the things that we've gone over in the past 2 weeks, along with some of the stuff we're going to be introduced today. There's a lot more information on here than you really need to know, but it's in a nice aesthetic format, and it's really kind of helpful, you know, different math functions, variable assignment. A lot of it's really helpful and useful. So I would recommend downloading it and possibly printing it out if you'd like. There's another data table cheat sheet that is also available in this R file. And this one's a little more complicated, but it's specific to data tables. So a lot of what we're working with in R about data science is looking at your data table. So this one provides a lot of the information about how to call out specific columns, how to work with specific parts of your data table. It's, once again, a little more complex than you need for this class, but if you're interested or if you want some additional information, these cheat sheets are really nice. In addition, I've listed out some of the definitions along with some examples that use a built-in data set in R. So if you need to brush up on statistics, this part is for you. For this week, you're going to be turning in your R script file, so this script file, and you're going to be running a t-tester and a ANOVA by doing these 9 steps. So the first 3 steps you should have already done last week: creating an R script, setting your working directory, and uploading your organized, cleaned up data set. Then you're going to name your data set as a variable. So for instance, last week I was working with table 1, but you can also name it anything that you want. Being careful to, if you want to have a space, make it an underscore or a period, and making it a name that isn't already frequently used, and being careful once again about uppercase and lowercase. Then we're going to be working with viewing your data, subsetting your data, and then running some statistics. So this is what I'm going to be going over in this video. All right, so let's go ahead and get started. First, this is my R script. This will be available for you. I recommend copying and pasting directly from my R script or working in your own R script. So you're going to be working right in here, doing some basic statistics. The first thing I want to note is there is a swirl course if you would like some additional help tutorial available right here in R. You can just execute this command. It'll open the swirl course for you. In the Word document at the bottom, there are also a bunch of additional links and tutorials that I've made available for you as well. So if you want some extra help, Google what you want help with, email me, look at this Word document, or do the swirl course, and you know, there's a lot of resources available, so there's no reason to be confused. In addition, once again, this is your R script file. The question mark will help you bring up a help page. For instance, question mark mean will bring up the help page for what is a mean. There are 2 different means, one in a base package, one in a BioC generics. We haven't downloaded this package, so we're going to assume that it's the one in the base. And then it tells you all the information that you need to know. In addition, here we are working with built-in data sets. So you can either use your own data set for all of these different manipulations, or if you want to practice, you can copy my code exactly and work with it in your own R. I also want to make a note that if you haven't already figured this out, you can drag these up and down if you want to see more of a specific area at any given time. You can drag these over as well. So I like to keep them kind of, you know, however works for me at the time. You do what works for you. All right, first things first, you got to get your working directory and then set your working directory. Then we want to, for this lesson today, run this code. We're going to install the Dipler package, and we're going to work with the Dipler package. So I've already installed it and loaded it. It's going to try to make me restart R. So this comes up. I've already loaded it, so I don't need to restart it. You can restart it if you are loading this for the first time, but I'm just going to hit cancel. Library Dipler is what we're working with. Okay. We're also going to be working with built-in data sets, as I mentioned before. So these built-in data sets are the sleep data set about students sleeping, cars about mileage and distance, or speed and distance, MT cars, which is about another car data set about all these different types of cars, US arrests based on urban population, rape, assault, and murder charges. There's also another one called IRIS. Just as a quick note, remember as you're typing, R is trying to help you. It gives you all the information that's available in terms of what IRIS things are available in R right now, what's in your environment, what it knows to happen. You can scroll up and down. And it also gives you some information about what thing you're selecting at any given time. So this IRIS data set, you can see it's a data set given from the measurements of flowers for 50 flowers, and it gives you some, just additional information. So this is the IRIS data set. So when we want to look at our data set, we have some basic commands that just help us visualize parts of our data. Those simple commands are head, tail, and summary. Head gives you the first 6 lines, tail gives you the last 6 lines, and summary tells you about the basic statistical analysis for each of your columns. So looking at sleep, this is based on the average amount of sleep a student gets. So we have the extra amount of hours that this individual student get, what group they were in, and what ID they had. So if we just want to look at the first 6 lines, we do head. If we just want to look at the last 6 lines, we do tail. Then for summary, this is going to summarize all the available columns. So the columns are extra, group, and ID. It gives us the median and then interquartile ranges for extra. It gives us group values. There's only 1 and 2. There's 10 in group 1, 10 in group 2. And then it gives us the ID. So all of them have an ID of 1 through 10. So there's 2 of ID 1, 2 of ID 2. We can do these commands for pretty much all types of data sets. This should work directly on your data. If this isn't working on your data, then please email me or Google what error you're getting because you haven't uploaded your data correctly. Also, as a quick note, remember, like we were discussing last week, this is from last week's assignment, you want to assign your read CSV command to some sort of name. So this is a data set about groceries. I named it groceries. Now when I just call the variable groceries, I haven't run that, sorry. When I just call the variable groceries, I get this whole data set, but when I want to call it, I only have to type in the word groceries. So it's the same, right? If I type in groceries, I get a full data set. If I type in iris, I get a full data set. So making sure to name your data set before you work with it at all. All right. We can do the same head, tail summary for iris. We can see that iris, has a lot more columns with data, not just levels, groups. But then one of the things that's important is mean, median, mode. Mode here does not refer to the value that occurs the most times. It refers to what sort of variable you're working with. Is it a data frame or a matrix or a list? So if you run the command mode, you're not going to get the value that occurs the most often. You're going to get what sort of variable you're working with. All right, there's also the data set cars, which will work with the first 6 lines, the last 6 lines, and a brief summary. MT cars, same thing, head, tail, summary. We can see that this works on pretty much all types of data sets. So head, tail, summary, very useful at just visualizing part of your data. Also works for, I'm sorry, I switched over to the terminal. That's what just happened here. So you don't want to be over in the terminal. You want to still be in your console. So US arrests, same thing. And as a note, looking at these data sets, right? So looking at US arrests, you want your data to look similar to this, where there's 1 row of headings for the columns, 1 row of headings for the rows. Each column and row has valuable information. They kind of seem to be in all the same format. While it could have a lot of different rows or columns, it still looks to be really organized and easy to work with. We're not doing advanced data science. We're doing really basic data science. So having a basic clean table is pretty important. All right. So once again, make sure that you're naming your CSV file so we can call it again to look at. One other note, Iris is one of the built-in data sets. If you want to view this data set as its own data table, not just in your console, you can type in view with a capital V. So we can see here, I had running that code, I have another table that pops up in my files. I can see the entirety of the table here. So I can know kind of where I want to target, what the different headings are, what my data look like overall. View with a capital V will do that. You can also look at the dimensions of your table. So if I wanted to look at the dimensions of iris, I type in the code dim, so dim iris. You can also get the number of rows by in row. So this is for number of rows. So there's 150 rows. We can see that that is true. We can also get the length of a specific column in iris. I'm going to go over this nomenclature in just a minute, but know that length is a command for getting how long that specific list is. So for this, it's the same as the amount of rows. We can also get a count of how many species are available in the data set iris. So if we look at question mark count, we can see that there are multiple ones available. They're both the same. So we're looking in Dipler. Count is saying that it lets you count the number of unique variables that are occurring in a data set. So the way that you do it, there's obviously an example here now, but you can also use count for a variety of different ways to determine how many unique variables there are. We can also use nomenclature to select certain parts of your data set. So this is going to become very important for subsetting your data, and this is an important part of what we're doing. So once again, I'm using iris as an example, but you can use any of the built-in data sets, your own data set as an example. So if I look at iris, my headings for my different columns, I want to use the command head. I can see that my different column names are sepal length, sepal width, petal width, species. So if I want to select a certain column, I can name the data set, use brackets, and then use quotation marks to call out that column. So for instance, iris quotation sepal width will give me this column, this one right here. So it gives me just that one column. If I wanted to do that with MT-cars, I would look at what columns are available for MT-cars. Okay, I have miles per gallon, cylinders, phelon. So then I can do, I want to look at MT-cars, bracket, MPG. Oops. So MPG is just this first column here. It's the title. Make sure to put it in brackets. Make sure to put it in quotations. Make sure that your spelling matches this directly. And then it should pull out just this column. Yep, just that column. We can also do this again with USA arrests. So US arrests, I can see I have murder, assault, urban pop, and rape. So if I wanted to do US arrests and then bracket murder, it should give me just the murder column. So we can see here in Florida, we have kind of on the higher end of the amount of documented murders. This is one way of calling out select columns in your data set. If you wanted your data set to become this new pulled out column, you would just need to rename this as a new variable. For those of you who are visual learners, this is what I mean. All right, so head, I look at all the different variables here. Then US arrest, I want the first column for murder. If I wanted to look at this as a new data set, I could do data set new and then use this same code. And now my variable data set new is just that column. And if I wanted to look at the head of this data set, I can still treat it as a normal data set, but instead of having all of the columns of the original USA arrests, I'm only working with the one column that I've called out. So that's kind of creating a new data set from this data set by calling out a specific column. You can, along with using this quotation, calling out the column name, you can also use the nomenclature that I mentioned before, which is bracket row column. So Iris, once again, this data set, we can see we have, in terms of dimension, we have 150 rows and 5 columns, row column. So if I want to call out all of a certain column, so maybe I want to call out all of petal or petal width. So 1, 2, 3, 4, this is my 4th column. I want only this column here. So I know I want all the rows, so I leave it blank. And I want column 4, so I type in column 4 to here. So this should give me column 4. This is slightly different in format than if I were to type in petal width and call out this column. Here it's giving it to me as still in the column format within a data frame type format, and here it's giving to me as a list. So depending on how you're trying to work with things, sometimes it's easier to call it out as a list or as this still like portion of a data frame. If you wanted to call out a specific portion of Iris, so say that I wanted column 4 and row 10. So I would do Iris, row 10, column 4. Remember, it's row and then column. So I should get 0.1. So I'm able to call out this specific data point in this data table by using the bracket row column. I can also get all of the information in row 4 for all of the columns if I leave columns blank. So leaving row blank or columns blank means that you can, you're selecting that entire column or row. You can also use the command names to pull the names. I tend to use head just to see what the top of the data frame look like, but you can also use this command names to figure out what are your column names. You can use names and then specify what row you want if your rows have different column headers. For this class, they shouldn't, but just know that names is another command that you can use. One thing that's really helpful and important is the $sign. You can use the $sign to call out specific columns. So before I had to do Iris, bracket, sepal, length, and in close parentheses, close bracket, run this, I get this whole column. But instead of doing that with the brackets and the parentheses, you can just use the $sign. So you can see here, this gives me the exact same column as sepal length and also as when we're denoting it with just numbers, but it's a lot faster to write this, and it makes a lot more sense sometimes when we're going to look at it later. So $sign, really important. Empty cars, if we want to pull out just empty MPG column, $sign. Sleep, if we want to pull out just the extra column, $sign. Once again, make sure that you're spelling these correctly and you're paying attention to uppercase and lowercase. If we wanted to create a new data set like we did up here with data set new from only select rows of our columns, we can do that using the $sign, or we can do it using the way that I presented up here. You can create new data frames subsetting your current data. So for instance, if I want to look at Iris, so Iris, once again, it looks like this. I have it pulled out here. We have all 150 different samples that are of different species, have all these different information. So if I want to really only look at a data set that's looking at 2 of these columns instead of all 5, I can do that very easily. And here's how I would do it. I would call out column with sepal length, and I would call out the column with petal length, and you can combine them together, creating a vector using C. So you learned this in Swirl. We went over it a bit last week. You're using C to bind these columns together. You're creating, you're binding them together. So you can run these, bind them together, and you can create a new data frame using these. But one thing that you can notice right off the bat is that this isn't creating new columns. This is just stitching those together. So we're creating a new vector by making it longer. We're making it, we're making it 300 lines long instead of 150 and 150. So while this can work for binding together different columns, we're just kind of grouping data sets together. We're not actually making a new subset of data. So what we would do to make a new subset of data is the same thing, but instead of C, we're going to use data frame to try to keep them in a data frame format. So I'm running them as these named as a variable, which means every time I run them, I don't get the whole data table that pops up. But I'm going to run this iris3, and you can see that instead of 300 values together as a list, I still have them as two separate columns in a data frame. So now my data frame for iris still has 5 columns, but my data frame for iris3 only has 2 of those columns. So if I'm really only interested in 2 or 3 columns from my bigger data set, sometimes it's easier to create this subset of your data. You can also do this in a few different ways, using the numbers, using the $, using the quotations. But make sure that you're not using C unless you mean to. You're using a command like data frame. When we're looking at maybe only removing a very select amount of data, not creating a whole new subset, there's an easy way to do this as well. So once again, looking at iris, say that we have one column that's just really not good. Let's say column 4 was collected by a really bad researcher. We don't believe the data. We want to get rid of it. We can use the negative sign like this here to remove that row or column. Right now I have it in the row area. So I want to remove row 4 from all columns is what this is saying. Remove row 4 from all columns. So when I run this and I look at my new iris 4, we can see that there should be no row 4. Nope, 1, 2, 3, 5. So I've removed that row. And so now my new data set, iris 4, has all of my original data except column 4. Row 4. We can also remove multiple rows. Maybe there's more than one bad row. And we can do this by using the bind C command again. So if I want to remove row 4, 5, and 8, 4, 5, and 8 from iris, then I would do iris, the same bracket, right? So this is row, this is column. But for row now, I want to remove multiple rows, which means that I'm going to make it row 4, 5, and 8. But you can't just type in 4, 5, and 8 to here. It gives you an error. It says, I don't know what to do with this unexpected comma. And it's because you're missing this C command here that binds those together. I want to remove both column 4 and column 5 and column 8. So now running this, I can see that I have removed one iris 5. We can see that I have removed column 4, 5, and 8. If you want to do this for, I remove rows 4, 5, and 8, but I was getting ahead of myself. You can also do this for columns. So if you want to keep all 5 of these columns except for column 2, instead of subsetting like this, it's easier to just remove a column. So instead of using the negative in the rows, I'm going to use it in the column. I'm saying I want to remove column 2 from iris, run this, looking at iris 6 now, and we can see that now I only have 4 columns and I'm missing sepal width. So I've successfully removed it. My new iris 6 data frame has only 4 columns. All right, so this kind of has shown you how to subset your data, how to remove specific parts of your data, how to move columns and rows, how to call out certain parts. how to use the $sign. And this builds on our class last week where you uploaded your CSV file, and then you can check briefly the dimensions, the head, tail, building upon what we went over last week. One thing that we're going to move on to now is by doing basic statistics. So median, max, mean, mode of your columns in your data. So I'm going to be working with mtcars. You have this built into R, if you remember. And remember, we can call out specific columns and rows or specific data points in your data set by using brackets, row, comma, column. So if I want to look at mtcars, all of row 1, you can see that this is going to be my miles per gallon, all of column 1. And I want the median of all of column 1, 9.2. If I were to say I want the median of mtcars, mtcars bracket mpg column, and run that, it doesn't like that. It doesn't give me a value for that. So even though I can run mtcars and get this as a column, when I'm trying to run the median of this column, it says need numeric data. So if you're getting a value like this, it doesn't like something about this column when you're selecting it like this. If you're doing median and then mtcars $mpg, then it'll give it to you again. So you have to be careful about how you're trying to use median for your command. So it's asking for you to use numeric data, meaning like put in your number like this so we can look at just the numeric data here, but you can also use the $sign. One thing that you might have noticed is when I was typing mtcars and I do $sign, it shows me all of the different variables that are available to write after the $sign, which is a really helpful thing. So you don't have to keep looking at the head or looking at your data set. You can see all of the columns that are available here. All right. If we want to look at the median, we type in median. If we want to type in mode, we type in mode. So once again, looking at that column, we can use this, or we could use mean, mtcars, mpg. If we wanted to look at the mean of another column, you can just select another column. So mean mtcars of HP. And it'll give you the mean there. We can do this for a lot of the other data sets. Let's look at USA arrests, and we can see that, let's look at the mean murders throughout the whole US, 7.78. If we want to look at the median or the mean of one specific row and multiple columns, so looking at mtcars, if we wanted to look at the median of this row, row 1, but we only wanted to look at the median between columns 2 and 3. We can try to do that by using these numerics. I want row 1, columns 2 and 3. If we run this, it says we need numeric data. It doesn't like that. So if you're trying to run something really silly, like getting the median between here, a lot of times it'll give you an error, like we need the numeric data. So sometimes if you are getting errors like need numeric data, but you know their numbers, it's not necessarily because you're not giving it numbers, it's because you're typing in something wrong. So I would do question mark, median, kind of see what it's asking for, what sort of arguments you need to put in, and how to get there. You can also copy this and Google this error and see what other people online are saying. R is open source, free, has a lot of online platforms, discussion groups. So getting the median of one column at a time, not two columns in a single row is what you need to be doing, not this. So I'm going to make a comment like, this is not good code, not running appropriately. One of the big things that I think could be an issue for everybody is the addition of NA in your data set. So sometimes if you're reading it in and R doesn't know what to read it as, it assigns it a value of NA. And then it's really hard to run any sort of statistical analysis because you have all these NAs around, where sometimes they should really be a 0 or they should just be removed. So you can go through and remove any columns that have all NAs or a lot of NAs, but there's also this handy feature for median, max, standard deviation, and variance, where you can do NA remove equals true. So for your data set, I would copy this, paste this into your R script, change this to your data file name, and run the median on all the different columns that you'd like to see, leaving NA remove as true. So if we look at mtcars, we can see that there are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 different columns. And we can call out any of these different columns. They all look like they're numerics, numbers. So here I call out all of the rows in column 7, and I want to remove any NA values that are there and get the median. I can also, so I'm looking at 1, 2, 3, 4, 5, 6, 7. I'm looking at the median of this column here, QSEC. So the median is 17.71. The mean is 22.9. The standard deviation is 1.78, and the variance is 3.2. I would, running your data sets, copy these in your notebook or copy these into your presentation and remember them, because as a reminder, they aren't going to be saved in your script. They're running in your console. This is not being saved. So copying these down, noting these, I would say is important later. You can do these for all the columns that you're interested in, any of the areas of your data set that you'd like to see the median, max, standard deviation, and variance. Okay, so this is all I'm going to do for this first video. I'm going to post another video about running t-tests, ANOVA, dealing with strings, and dealing with dates. But I don't want to make the videos too long. I already have probably less than half of the class watch the videos in the first place. So I'm trying to try my best here. All right, I hope everybody has a great week, and please email me with any questions. Take advantage of Google, and I hope you have fun working with your data. All right.